Hey guys, Chris here, back with another video, and this is a series where I essentially work on a problem that I've never seen before from LeetCode. We're currently working on easy problems, and we'll probably move up to medium problems in a few videos. This is mostly to get a feel for this and see if people are actually interested in this idea. So again, haven't seen this problem, so let's go ahead and see if we can solve it. So given the problem is called middle of linked list. Given a non-empty, singly linked list with a head node and head, return a middle node of linked list. Return a middle node of linked list, okay? If there are two middle nodes, return the second middle node. Interesting. So the problem seems relatively straightforward. So here we have 1, 2, 3, 4, 5. Here we have 1, 2, 3, 4, 5, 6, so we'd want to return 4, and here we would want to return 3. So this actually reminds me of another problem that I've seen before, where essentially you want to see if there's a loop in the list. So the way that you would do that problem is you would have one counter which moves one at a time, and then another one which moves two at a time, and you see if the first counter is ever equal to the second counter, or the first element is equal to the second element as they're going around in a circle. So I believe that we could actually do the same thing here, except instead of seeing when it's at the end, instead we just use, whenever we get to the end for the second counter, we just use wherever the first counter is. So for example, let's say we start them both at 1, right? We'll start the second one at 2, and then we'll start the first one at 1. And then we move one by 2, which would reach 4, and the other by 1, which would reach 2, and then move the other by 2, which would reach the end, and then we move this one by 1, which would reach 3. So we have to move the smaller one first if we would want this to work, because then we see, oh, there's null here, so we know that we're done. So let me try to do it the other way and see if that actually works. So we move 1, and then the other one is 2, and then 1, and the other one is 4, and then 3, and then we hit null, so we return 3. So that works for the case where there's an odd amount. Let's see if it works for the case where there's an even amount of elements. So 1, and then 2, 2, then 4, 3, then 6, 4, then outside. So it looks like that works for both problems. So I believe it should always work in every case. So we have our head. So we're going to want to say, so I want to essentially code this algorithm. And the way that I think about doing it is essentially just have some variable that records the position, records each element, and then we do the double next and the non-double next and just look for when it's not there. It'll make a little bit more sense as I'm coding it, I think. So let slow node equals head, and then we're going to let fast node equals head.next, right? And then we're going to want to say while true, we just want a loop that goes on forever. We're going to want to say slow node equals slow node.next, and then we're going to want to say fast node equals fast node.next, and then we're going to want to do that same thing again. Fast node equals fast node.next. So the tricky part about this problem is going to be dealing with all the corner cases and edge cases and making it dry, right? So then at the end, we're going to want to say something like if fast node is null, return slow node, and essentially we could have this twice. And I believe this would work, but again, we want code a little bit more dry than this. Because like while I don't, in these types of problems, you generally don't care too much about making everything perfectly pretty and stuff, but like this is very non-dry code, and this is a little too excessive even for me. But let's go ahead and see if the general concept works. So slow node is head, fast node is head.next. So is head always guaranteed to be something, or could head be null? I believe head, given a non-empty, okay, so it's non-empty, so there's at least going to be a head. So head.next will always exist, right? So this is good. Okay. Okay. But also here, there's another potential issue. If fast node is null, we would just want to return head because that means there's only one element in our list. And then we would run into an error because slow node.next would work, but fast equals fast node.next would not work because fast node would already be null and it would throw an error because we would be trying to call null.next. Okay, so assuming that there's more than one node, which is essentially what this checks, we want to keep on doing this iteration, right? So slow node equals slow node.next, so it would equal the second node here, which would equal 2. And then fast node equals fast node.next, which makes it 3. Fast node equals fast node.next, which equals 4. Fast node is still not null. And then we go through it again. Slow node, which is 3. And then fast node keeps on going, and then it runs off. And then what we want to do is whenever we find that fast node has run off a cliff, we want to just return slow node. And let's properly put that in. So let's go ahead and run the code. Hope that doesn't fail because this would be an infinite loop otherwise. So that test case looks like it works well. And let's go ahead and try this one and make sure that we get the answer that we would expect. Cool. So output 456, expected 456. I'm very confused by the output and expected, but regardless, it appears to be working, and I believe this should work in every case. So let's go ahead and submit the solution, and then we'll clean up the code if we pass. So cool, we do pass. So we don't want to do this twice. Well, we do want to do it twice, but we don't want to do it like this because that's not dry. So we can do a simple for, let I equal 0, I is less than 2, and then we increment I. So we should essentially just do it twice here instead, and then we can get rid of this other stuff so we don't repeat ourselves. So I equals 0, increment I, still less, increment still less. Cool. So again, this should still continue to work. Our code is actually likely to get a little bit slower here. It's actually the same exact result. Cool. Since we're doing a loop instead of just doing it properly, it usually adds a tiny bit more overhead, but the drier code is definitely worth it. Cool. Slow node equals slow node next. Okay, I want to see if there's any other way potentially to optimize this code. So there are potential things that we could do so we don't have to have this base case in here and things along those lines. But this code is satisfactory for all intents and purposes. There's no silly things like having very undry code, and it functions properly and is fairly clear on what it's doing. So yeah, that's it for this one. Thank you.